The goal of this video is to explain specific heat. We'll start with a definition. Specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. The goal of specific heat is to tell us how easy it is to heat up a substance. Every substance has a unique specific heat. Let's break down the definition to understand better what it means. First, let's answer the question, what is heat? Heat is energy traveling from something hot to something cold. An example would be a flame versus a chunk of ice. The flame has more heat, so we are going to see the heat travel from the flame to the ice. The result, of course, will be that the ice will melt into water. When energy moves in the form of heat, it is lost by whatever was hot and gained by whatever was cold. We can measure this exchange of energy with temperature. Whatever loses the energy experiences a drop in temperature. Whatever gains the energy experiences a rise in temperature. What is temperature? Temperature is ultimately a measure of how active the molecules of a substance are. All molecules are always moving. Gas molecules just move much more and faster than molecules in a solid. When a thermometer is struck by molecules in motion, some of their energy is transferred to the liquid in the thermometer. The added energy causes the liquid in the thermometer to expand. The markings on the thermometer relate this exchange of energy to numbers for us to use. We measure specific heat using the Celsius temperature scale. If you're used to Fahrenheit, it may help to know the relationship between the two. 1 degree Celsius equals 1.8 degrees Fahrenheit. So when the temperature outside increases by 18 degrees Fahrenheit, that means it's gone up 10 degrees Celsius. Now let's look at how much is a gram. The average person tends to think of grams as weight, but weight measures how hard gravity is pulling on something. Instead, grams measure mass. Mass measures how much matter is contained in a substance. Some examples of things that have a mass of 1 gram would be a standard-sized paper clip, a dollar bill, an unshelled peanut, or a common housefly. Another thing that weighs 1 gram is 1 milliliter of water. That is the same as 1 cubic centimeter of water. 1 cubic centimeter is smaller than an average dice. An average die measures 1.5 centimeters per side. So a cubic centimeter of water is about 1/3 the volume of an average dice. And that 1 cubic centimeter of water weighs about 1 gram. Now let's read that definition again and see if it makes a little more sense. Specific heat. The amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. As I was explaining the definition, I talked about Celsius, Fahrenheit, grams, milliliters, and centimeters. You know all these words as units of measurement. They are each for a particular type of measurement: temperature, mass, volume, or length. There are also special units for measuring energy. Remember, heat is a form of energy. Those units are either calories or joules. The joule is the smaller unit, like a cup is less than a gallon, but both measure volume. How much energy is a joule? Well, if you count out 100 peanuts and seal them in a baggie, that would equal about 102 grams. Next, you want to get out a meter stick. A meter is about 3.5 inches longer than a yardstick. So you see here I have 3 foot rulers, and then 3.5 inches on top of that to represent a meter stick. Now I'm going to take my bag of peanuts. These are shelled peanuts, by the way, even though my picture has peanuts in the shell. I just couldn't find any shelled. And you want to lift those at a steady pace for the distance of 1 meter. There. And you have expended 1 joule of energy. Now let's look at the other energy unit. The calorie listed here is not the calorie you are used to. That is called food calorie, and it is actually worth 1,000 chemistry calories. So when I talk about a calorie in terms of specific heat, I mean a chemistry calorie, not a food calorie. And how do these two energy units relate to one another? Well, 1 chemistry calorie equals 4.184 joules. Now let's put these measurements together to understand specific heat better. 1 chemistry calorie, or 4.184 joules, is the amount of energy necessary to raise the temperature of 1 gram of water, which is 1 cubic centimeter of water, by 1 degree Celsius, which is almost 2 degrees Fahrenheit. And there we have the specific heat of water. So this is specific heat. For water, it just happens to measure exactly 1 chemistry calorie, or 4.184 joules. Every substance has its own unique amount of energy required to raise the temperature of 1 gram of sample by 1 degree Celsius. Since it's more common to measure specific heat using the joule unit of energy, let's compare the specific heats of some different substances to water using the joule unit. Water, of course, is 4.184 joules per grams degree Celsius. Glass is 0.837 joules per grams degree Celsius. Iron is 4.2 joules per grams degree Celsius. Copper is 0.385 joules per grams degree Celsius. Silver is 0.235 joules per grams degree Celsius. And gold is 0.128 joules per grams degree Celsius. So what do I mean by those units? I mean for every 1 gram of substance that is raised by 1 degree Celsius, it takes a certain number of joules of energy. For water, that's 4.184. The lower the number you have for specific heat, the easier it is for that substance to absorb heat, so the easier it is to heat 1 gram of sample. So from our short list, gold is the easiest substance to heat. Its temperature will go up the fastest. Also, you can see that water's value is quite a bit higher than the others. Water doesn't heat up or cool down as easily as other substances. Specific heat is typically used in calorimetry equation. What is calorimetry? Calorimetry is an experiment which measures the exchange of heat. Here is one example. We'll start with an insulated container which contains water and a piece of metal which is heated. Now if we take that chunk of heated metal and we put it into the insulated container, which is called a calorimeter, and we add a thermometer, we can measure the change in temperature of the water and determine how much energy the piece of metal loses as it cools down. Since heat energy always moves from hot to cold, the metal will continue to lose energy to the water until they're both the same temperature. Finally, let's take a look at the specific heat equation. Most often you will see it in this form: Q equals mc delta T. This equation lists 4 different measurements or variables. If we know any 3 of them, we can solve for the other. Let's see what each variable represents. Q equals the amount of heat absorbed or released. This will be measured in either joules or calories. M equals the mass of the object. Mass is measured in grams. C represents the specific heat of the object. Specific heat again is measured either in joules per grams degree Celsius or calories per grams degree Celsius. And then we have delta T, which means change in temperature. And this will be measured in degrees Celsius. To find the change in temperature, you subtract the initial temperature from the final temperature. Being able to solve the specific heat equation then allows us to use a calorimetry equation. Negative Q object equals Q water plus Q calorimeter. Q again representing the amount of heat absorbed or released. Notice that there's a negative sign in front of Q object. This is representing the fact that the object lost energy. However, that same energy was gained by the water in the calorimeter. This completes my explanation of specific heat and how it is used. If you need help with calorimetry specifically, watch the video on this channel titled Step by Step Through a Calorimetry Problem. Thank you.